In this video we're going to talk about design documentation. We're going to use the Tealight stand as an example. I've got a previous video of how to model up the Tealight stand in SketchUp, and I'm going to refer you to that model there. Now the design document has some contents, and this is based on a blank document, a template document that I hand out with the tasks. First section in the document is going to be the design brief requirements. You should hopefully have seen this model before, by the way, but we're going to start there. That's after you've done some investigation, but the investigation is not part of this design document. The next step is going to be to include some design drawings. Now between these two steps there will be a process of creating these design drawings and modeling the actual object that you're going to be making. Now you can do this by hand with sketches and drawing board drawings if you like, but hopefully what you're doing is creating a SketchUp model and exporting some images from there. Once we've got design drawings or got the design worked out, we're going to create a parts list. We're going to use the model to help us do that. But we're going to first create a parts list. We're then going to take that parts list and move on to a cut list. Once we have everything worked out up to there, we should be putting together a plan of how we're going to go about making the object that we're going to be making, the Tealight in the stand. And the last thing that's in the document, but it happens all the way along, you should be dropping to the bottom, doing an update and going back to where you are, is that you should be recording decisions. So specifically you record what decisions you make and why you make them. So we're going to start with the design brief, and the design brief as always is split into three parts. The functional requirements to detail what the item does, the sizes of items or components, or perhaps the quantity of components. There will be other functional requirements, and this is something you may not have a lot of say over. This will come to you in the task sheet, and a lot of the functional requirements will come straight out of that, but there may be aspects of functional requirements that you can either modify or add to, and if so, please go ahead and do that. Aesthetic requirements, specifically what it looks like, the appearance, and this is very much where students get to have the most input into projects. Again, some of it might be virtually specified by nature of the project, but a lot of the projects, the aesthetic requirements are quite flexible, and that's where it's open for you to make the project your own. The last thing in the design brief are constraints, and once again this is going to be largely dictated to you, but there may be other constraints that you bring in. There'll be things that you can or cannot do, there'll be materials that you can or cannot be used, there'll be sizes maximum and minimum, and here is an example. If you were to be building a desk, you would go to your home and measure the space you have available. That would determine your maximum dimensions, and that may or may not be different to the maximum dimensions that you're given in the actual task brief. And of course quantities may happen, so a chest of drawers, you might actually say there are a maximum or minimum number of drawers, or maybe a cabinet may have a maximum minimum number of doors. Those sorts of constraints will be put onto the project. So an example of the design brief for the Tealight, the functional requirements, we've kept it simple, 3 Tealight candles. So we're going to determine how many we want, and that's about all. Aesthetic requirements, we're going to go for a combination of light and dark wood. We want the candles fully recessed into holes drilled into the wood. We don't want them sticking up a little bit or just resting on the top. And all we're really saying is dimensions that are in proportion with one another. We're not specifying any dimensions, they just have to be in proportion. And the only size that really is going to determine that is the candle itself. That's specified as a constraint. The Tealight candle dimensions are 38mm diameter and 15mm high. We also have a constraint about various available timber dimensions in the workshop, so that's in terms of width and thickness. And we've got, for instance, 42 by 12, 68 by 12, 140 by 12mm, or the same range of widths is 42 by 19mm thickness, 68 by 19, or 140mm by 19. So you get those 3 widths and those 2 thicknesses, and we've got the combinations of them as we go along. We then move on to the design drawings, and as I said, I'm not going to go into the modeling process for SketchUp, that's a subject for different videos, but basically once you've done your model, we want to obtain drawings from SketchUp, and the idea is that you're going to create a scene for every drawing that you want to export. We're then going to paste the exported document into the design document within the drawing board as provided, and then we're going to crop and resize, and the example below is with it pasted into a drawing border. But then we move on to what it might look like if you cropped and resized to get rid of the SketchUp logo and to fill the space available. And then just a quick reminder, the ones that I've shown here have no information in the title block. Please remember to fill in the title block. So some notes about design drawings. The drawings themselves are placed in an appendix at the end of the document, and that's because of the landscape orientation of the drawing borders. It's much easier to keep all the text in portrait format as we go along, and then when we get to the drawings we switch across to landscape format and paste the drawings in. And that means that a list of drawings should be placed in the body of the design document, so you've got something in the right place in the document to say, hey, we've got these drawings as part of the design. An example of that is what you see below. Drawings as a heading, please refer to the attached sketches and drawings in Appendix A at the end of the document, and there's a list of the drawings. Those titles come from the title block. So from here we move on to parts list, and the parts are the pieces that get assembled to make an item. Think about something that comes from IKEA. You open the box and there's a whole list of parts, and they don't have a list so much as a picture with a set of numbers, but that is a parts list. It's what's the contents of the box. All the bits and pieces that need to get put together to make one single item. Now in SketchUp, these are typically components. They could be groups, but components work better because you can go to your components list and that'll help you to compile your parts list. Now the parts list will tell you what different types of parts are required. It'll tell you how many of each part is required. It'll give you overall dimensions of length, width and thickness, and it'll tell you what materials each part is made from. Now the IKEA parts list don't have those last two because they've already made them, but we've got to make them. We've got to actually go and use this parts list to compile the cut list. We're going to be using those 2 points to do that. What the part list does not tell you is it does not list components of parts that have already been assembled. Now again, think back to the IKEA example. If you're buying a cabinet from IKEA and it's coming with a door, and if it's what's called a panel door, that has been made up of 2 rails, 2 stiles and a back panel. They're not going to list those separately in the parts list because it's already been joined and assembled and you're pulling it out of the box as one item, one part. So it doesn't actually mention the subcomponents of parts that have been assembled, nor should it. And it also doesn't provide dimensions or details of things like joints, cuts out, spaces, protrusions, or anything other than the basic maximum regular shape of the wireframe around the outside of the part, whatever the part will fit into. And that's because the drawings do that work. That's not the job of the parts list. So here's an example of the parts list for the Tealight stand, or the Tealight. We have one spine, that's the long bit down the middle. It's 300 millimeters long. It's made from 42 by 12 millimeter pine. We've got 3 ribs. They're only 120 millimeters long. It's also made from 42 by 12 millimeter pine. We have 3 candle blocks. They are 60 millimeters long. It's made from 60 by 90 Meranti. And we've got 3 candles. They are 38 by 38. They're actually 38 millimeter diameter. But we've got length and width 38. The thickness in this case is the height. And the purchase item is the type of material, because we might know that it's made of wax and it has aluminium around it, but it's a purchased item. We don't need to know the actual materials as such. Now the parts list helps us to compile the cut list, and a cut list is something similar to a shopping list. You will not be able to go along to a shop and say, hey, here are my pieces and parts, can I have all of them off your shelves? And they don't sell timber in that way. Timber is sold in different lengths of standard combinations of width and thickness. So I can buy timber that's 140 by 12 millimeters, 140 wide, 12 millimeters thick, and I can buy it in lengths that range from 1.8 meters to 5.6 meters. I can go buy 42 by 19 millimeter timber in the same range of lengths. It's probably every 300 millimeter increments. I cannot go and buy 457 millimeters. They will not sell it to me. Plywood, on the other hand, is sold in different size boards of standard thicknesses. So it's 2420 by 1210 millimeters, which is a pretty big board. That's a standard size. 910 by 605 is a whole lot smaller. But the standard thicknesses are 3 millimeters, 6 millimeters, 7 millimeters, etc. You don't get 4.23. It's just you get what you get, and the characteristic dimension for plywood is its thickness. Now, timber merchants and hardware stores like Bunnings and Stratco can cut material to smaller. It's done at a cost, and there are some limits on what materials and sizes they can cut. So for instance, Bunnings will not cut 3 millimeter MDF, and nor will they cut something that's going to be 103 millimeters long. So you're going to have to do that yourself, and this is why you have to come up with a cut list, so that you can, or the cut list in this case is to get it from me, your shopping list, so that you can go and buy the total amount of material that you can then cut up into pieces yourself. Now, to create the cut list, we're going to group materials together that are of similar type and have similar characteristic dimensions. We're going to determine the total length or the board size, and we're going to determine the quantity of each material type. and I'll show you what I mean about quantity in a minute. And we are going to allow for wastage. You must add some additional material on the end because you're going to lose material when you cut due to the curve of the saw, or possibly because of knots, or because the end of the material is a bit dodgy. So you do have to allow for a little bit more than you think you're going to need. Alright, and finally, just be aware of workshop constraints on the use of the table saw to cut to width. We have standard widths, but you're not able to use the table saw to reduce it to a narrower width, and so what I ask you to do is put each width that you use onto the cut list so that I can cut it for you in the table saw. You could cut it on the bandsaw if you're in year 10 and above, but the quality that you get is not going to be as good as the table saw, and it's also going to speed up work a whole lot if I can do it before you get to the class, and then you don't have to take the time setting up to do the job. So put it on your cut list and let me prepare it for you. Everything that is a standard, a particular combination of width and thickness, should be a separate line item on the cut list. So here's an example for the Tealight stand again. I have one piece required of pine, and it is 700 millimeters long by 42 by 12. So 42 by 12 is my characteristic size. I only need 700 millimeters. That's a reasonable size, so one piece is enough. If I needed 7,000 millimeters, which is 7 meters long, I couldn't do that with one piece. I might ask for instance, 3 pieces that are 2,400 millimeters long, and that would actually give me 7.2 meters. I could ask for 3 pieces like that. On the other hand, I can't fit a piece 2.4 meters long into the benches at the school, so I might end up cutting that down to pieces that are 800 millimeters long, in which case I'm going to need not 3 but 9 of them. Alright, then I've got one piece of Meranti. It's 200 millimeters long. It's 60 by 19 wide. Now 60 is not a standard width, so as I say, please put it on the cut list anyway at the width that you require, and I will cut it down for you on the table saw. It is much easier than you having to either cut it on the bandsaw or plane it down yourself. Now I've also added on or put back here the parts list, and I've shown you how the parts list becomes the cut list for the pine. So what I have is I have one spine at 300 and 3 pieces, the 3 ribs at 120 millimeters. When I multiply and add those together, I get a total length of 660 millimeters, and that becomes the length. I'm going to add a little bit more for wastage. I'm going to ask for 700 millimeters. You can see the material is pine and where that comes from on the parts list. You can see the characteristic width and thickness where they come from, and they go onto the cut list. You can also see I haven't actually highlighted it in this diagram, but the candle blocks, similar process. We ask for Meranti. I have 3 of them at 60 millimeters is 180 millimeters. I add a bit of wastage, so that's 200 millimeters length, and the material is 60 by 19 millimeters as its characteristic size. And that's the way that you compile a cut list. So we're going to move on to the plan, and plan is the process of breaking the task into steps, and we're only going to look at some of the main activities or significant activities. We're not going to look at every detail of every little step. We're going to create a new step for different activities, so cutting, routing, gluing, painting perhaps, whatever, different types of activities, each will get a different step. You may also create separate steps for similar activities but with different tools or methods. So for instance, cutting with a handsaw versus cutting with a miter saw. Making a rebate with a handheld router versus a rebate with a table router, maybe painting with a paintbrush or painting with a roller, different cleanup requirements, different paint requirements perhaps, there would be different steps perhaps. As you go along, make note of specific requirements for each step. That might be resources required in terms of tools, materials, assistance from someone, or you might want to make note of sequence of work requirements. So I need to complete this step before some other step, or I can only do this step after I've done something else. It's worth putting it in the notes as a reminder, and just so that you get your plan worked out properly in your mind. Once you've got all your steps worked out, list the steps in a basic order or sequence of work. You're going to be listing them in one long list, so you're not going to be able to list steps that have to happen alongside each other. Do your best and use the notes that I've mentioned to try sort out some of the ties of different steps of one has to be completed before the other. So here's an example of the plan. I cut pieces to length. In this case I'm talking about the spine and the ribs, and I'm using the miter saw to do that. I'm then going to cut the lap joints. I'm going to use the bandsaw and chisels. I'm going to move on to cutting the candle block housings, and I'm going to use the tenon saw and disc sander in this case. Perhaps we consider the miter saw dangerous because the pieces are too short. We're going to drill the candle holes. We're going to use the drill press for that. We're going to make clamping blocks. Now clamping blocks are not part of the project. And in fact, we don't even have it on the cut list. We're going to use scrap. But if you have a look to step 6, when we glue together, we need glue clamps, clamp blocks. We have to actually create them. If they're not readily available in the workshop, we have to go find some wood, get some packing tape and put it over the top so that they don't stick together, and have something that we can apply clamps to actually glue it together. A good idea to put it into your plan, because it's a step that will have to be done if it hasn't already been done by someone else. And the last step we have is to finish, which is paint with varnish. Alright, and this finally brings us to design decisions. Now, recording your design decisions is recommended because it helps other people, especially the teacher, understand what you're thinking. It helps to consider possible consequences in the design. So if changing something A to B means that I also have to change C, something else, a third thing, but C was decided on because of a fourth thing, D, well, then you have to remember to both remember and reevaluate this reason D before changing your A to B. Take some time, read over this, think about it. It should make a bit more sense. Basically, if I'm going to make one change, I'm going to make sure it doesn't cause problems down the line. And recording that decision means you should not forget when you're in the heat of the moment, when you're facing time pressures and dealing with the realization that whatever won't work and you need to fix it and you need to do it quickly. That is what happens. You make a rash decision and then you tend to regret it later. Recording your decisions might help you to avoid that. Alright, when recording a decision, write it down, or write down firstly what you've decided. And we've got 2 columns for this, so be brief and as brief and concise as possible and as precise as possible. And then write down why you've decided it. Now this may require a bit more explanation. You can go into a bit more detail on that. An example here of design decisions, I've said that the spine and ribs are going to be made from 42 by 12 mm timber. The reason why is because 12 is a standard thickness and 42 is an available cut width, alright, cut from it, and more than 42 mm is too high for the stand. We talked about the aesthetic requirement of something being in proportion, and somewhere along the line I've worked out that 42 mm is just right. Okay, I have a decision to make the spine and ribs from pine, the candle and blocks to be made from Meranti, and once again we have an aesthetic requirement of contrast between light and dark wood. So we've got both the decision of what we've decided and why. And that brings us to the end of the Tealight or the design document. I hope this document does help you to understand what it is. We have the blank document for you to fill in. I should have a completed version of this Tealight document for you to have a look over as an entire document. But hopefully this explanation on video helps you to understand a bit more as well.